Hello and welcome back to a new video in my C++ tutorial series. Now that we got all the pointer and type stuff aside, so now we basically know how pointers work, how to use them, how to create our own types and how to use these types as well. I want to go back to our Simple C app. But before we're going to do this and make sure that everything works and we get functionality in, I first want to make sure that the Simple C app is our startup project again, so that we can debug it and that we don't care about the pointers yet. So let me quickly close up the pointer C file. We don't need this. You can also, if you still have it uncollapsed, collapse it again so that it is compact and doesn't get in your way. Now you want to again right click on the 01 Simple C app and set a startup project here, and now if you press a 5 you should get the output from the Simple C app again that we had previously, like the f from 5 is 55, the f from 10 is 155, the f from 15 is 305, f from 20 is 505, and so on. So we now basically got what we need, and we want to now get started by adding input. So currently we are hard coding that. So all of our y values and x values are hard coded. We have an initial x, and then we are building kind of like a row of 1, 2, 3, 4, and this is all hard coded. I want to have that dynamically. We're going to start by making the x dynamic, and later on we're going to also make, in the future when we are getting to control blocks, we're going to make sure that this is dynamic as well. But today we're just going to focus on the input. Alright, so how can we input data in C? There is a function that you can use to input data, and we basically previously used print, or better to say printf, to output a formatted text. Now what we basically want to do is we want to input something with a formatted text. So basically we have an int x, which is in the future just going to be like that, plain x, and then we want to basically input something using a similar thing in here, but instead of basically writing some f, we just want to input an integer here, and when we inputted that integer we basically want to use it. So we don't want to print, we want to read something. Well, the function would of course be called readf if the function would also be called writef, but since it's not read write, it is print. And what is the opposite of printing? What does your printer have? Your physical printer? It has a scanner attached to scan data. So we don't want to print formatted, we want to scan formatted. So what we want to use is scanf basically. I want to use the scanf function to scan something. And the scanf function works very simple. You also have an argument and values. So now if you would want to use it similar that we had it here, so we want to scan into x with a format. We don't really care about something, we just care about the int. So I just copy the %i, and I just want to scan that %i into x, right? We are for a second gonna ignore that that green underline, and we're gonna start and see what we get. And we get nothing. Why do we get nothing? It's not what you mean. First of all, if we go to our output and take a look at what we actually got, where is it? That one. That is the error that we are talking about. The other ones are warnings. This is a warning. We don't care about the warning. We care about this error message. So what does this as an error message as? Let me maybe select something else so that we can read this a bit better. Scanf. This function or variable may be unsafe. Consider using scanf_s instead. To disable deprecation, use CRT secure no warnings. See online help for details. So basically the issue that we have here is that scanf is not meant to be used. This is now a completely Windows only behavior. Windows has the behavior to disallow the use of scanf because it is unsafe. Why is it unsafe? We're going to get to that when we get to strings. This only has something to do with strings, but we can use scanf to also read strings, and so it is in the group of functions that has been replaced by newer, safer functions. So scanf itself, unsafe. To make it safe, we use an _s. And we don't need to change anything else. If we add the scanf _s, we made the function safe and it now can use. And what we now can do is, after we are done with that, try this out again. If we now press F5, it is going to give us an error again. The error is that we use the initialized variable x. So we cannot use x when it is not initialized. So what we would do is basically just write a value of 0 to get a starting point. And if we do this again, the application blocks. Why does it block? It doesn't do anything. You could say, all right, there's something wrong, but it's actually not wrong because we called scanf. And if we are calling scanf, we basically want to input something. We want to input a text or a number. In our case, a number. So let me actually input the 5, which we had previously, and type it in. If I just type the 5 in, it works, of course, because we are scanning, we are waiting for input, but it's not going to do something. We need to accept our input because we could also like maybe say 55555. We need to accept our input by pressing enter. So I type in the 5 and press enter. And boom. Error. Debug assertion failed. Program, simple C app, file, core CRT internal stdio input.h line 1567 expression result underscore pointer unequal null pointer. For information how your program can cause an assertion failure, see Visual C++ documentation on assert. Press retry to debug the application. We want to debug this because we want to see where things get wrong, so I'm going to press debug and we're going to see what's going on. Alright, so where is the issue? The breakpoint is basically here. A breakpoint instruction was executed. Now this is a bit different than we had before because now we basically had an assertion failure. An assertion failure is a check that you can do as a programmer. We're going to get to assertions in the future as well, and we're going to write our own assertions, and these assertions are basically what caused this issue. But the assertion basically occurred inside of that function. stdio common vf scanff. And if we scroll a bit up, you can basically see that the function that was causing it is the vf scanf sl, which is somehow our scanfs, but kind of like obscured in something else. We can actually see what's going on by going back to the call stack, and we now can basically double click above here to see where we actually went, and you can actually see that we called this function scanfs. This is exactly what we called. Here is the scanfs function, and this function does some shit and calls a function which just basically catch the error. If we are going way up again, you can actually see that we are currently inside that function here. We are in that function here, scanfs, which we just implemented. So we made an issue there. Can we actually solve the issue? Yes. If I just exit this with pressing the stop button and hover over that, we already get the issue that we have. So the issue is actually a quite common issue, and the compilers or the Visual Studio is already detecting this and showing us what's going on. So what is Visual Studio telling us? It's telling us that we have an error of the error code C6066. Non-pointer passed as parameter 2, where pointer is required in call to scanf. Actual type int. So actually what scanf or the compiler tells us that scanf is actually expecting a pointer type, but it got an int type. Why does it expect the pointer type? Well, same issue that we had all the time when I introduced city pointers. We are now passing the value of x, but we don't really want to pass the value of x. So basically what we want to do is here, we want to call scanf to modify x. So we want to actually tell scanf the address of x. Where should it write the first data that it finds? %i, first parameter in the second argument here. Where shall it write that value that it reads? No, don't put the 0 in here. It's going to be interpreted as a pointer because it doesn't really care about what x is. We are printing. When we are printing, it's okay. We can just put a normal integer value out there, an x that gets copied, and then the standard code, the standard library code can print that copied value. It's all okay. But in this case, we don't really want to copy that value. We want to basically say where the value is. And if we want to do this here, we're going to make this to a pointer. You can see that the underlines disappear. And if I rerun this, we're going to start by getting the same behavior. But if I now would input 5 and press enter, you can see, all right, f from 5 equals 55, f from 10 equals 155, f from 15 equals 305, and f from 20 is 502. So the same output, but now using a user inputted value at runtime. If I would rerun this and maybe now take the value of 6 here. Can see f from 6 equals 71, f from 12 equals 209, f from 18 equals 419, f from 24 equals 201. So this works as expected. Now, actually, one thing that this code was already wrong was that we were not able to do something like that we already got this uninitialized local variable x used. If we're going to use this here as a pointer, you can see that we no longer get the issue. We can use it. 5 again, get the values. So basically we were already getting a hint there that something was wrong, because basically by supplying a pointer to a other function, the C compiler is going to assume that this function is going to initialize that variable x. So if we do it like that, x, and pass it as a pointer, basically the compiler sees, alright, it has been passed to another function, and I'm going to assume that the other function is going to initialize that variable. By doing this like that, as you can see, works. Run this again, add a value, computes the stuff. Seems all legit and working. But there's one thing that I don't like in this application. Okay, there are multiple things that I don't like, but one main thing that I don't like, if we start our application, it starts out like that. Which is not good, because the user does not get a feedback. The user thinks and sits there 10 minutes, 20 minutes, and the user just there and says, hey, the application doesn't work. Why doesn't it start? I started and it gives no output. And then the support says, yeah, you need to enter a number. And the user, why would I need to enter a number? It's just a blank window. Yeah, you need to enter the number that shall be computed. But why? And I never get prompted to that. And that is an issue. I don't like it. Well, of course I can do it and it works, but I don't like it. So let's fix that. I want to basically tell the user what he shall enter. Can we use that scanf for that? Maybe. Let's try out. Enter the value. Can we do this? Let's try this out. No, we can't. Actually, it doesn't work if we start it like that, because now I enter 5 and we get some garbage. Because actually what the scanf is now basically expecting is, if we do it like that, it is expects enter the value 5. And now if I do it, it works. So this is kind of like the wrong way around. And you might already know how to solve it. We need to solve it by actually adding a printf. So if I add a printf and say, or not a printf, I can just do a plain printf. It's okay. Enter the value x. If I do this like that, make sure to have a white space there. So if I don't have a white space here, I can show it to you. Basically, if I have this like that, you can see that this is all like connected together. It works, but here it's like, it's not nice. I want to have a white space here. If I add this white space here and run this again, you can see, all right, enter the value x, 5, enter. And now we basically have this nice and clean. We are basically want to get the x, printf, scanf for entering the variable x, and then you can basically say, all right, I want to have that value. Maybe now let's do something like 8. And if I enter the 8, it's going to process that very nicely. All right, so that's very nice, but, well, it is a bit big. And as you know, we want to write functions, right? C is a language that works with functions. So, of course, we want to have our own function that reads the x value. Since it reads the x value and we are expecting 32-bit ints, so int32t is a return type, and we want to say, we had this as print fx, so let's call it scan x to scan the x value. It's not going to get any parameter, it doesn't need a parameter because it's just going to contain that static code here. Let's take that function definition, scroll a bit down, and add the implementation here. What we want to do here is basically do this like that. No, do this like that. Don't cut something that we don't need. And scanx is gonna be here somewhere. And now down here, we're gonna do this similar. Of course, we need the x here again. So we're gonna put the x in here. And when we are done, we're just gonna return the x down there. And we are nice and set and everything works fine. X is gonna be initialized and it's gonna be read by the scanx function. Now I can do this like that and it works. Could also maybe, if we had a 2-parameter function, I could say scan x for y. It doesn't really work because of course we should We should see this here in the text as well, but we're going to talk about the text in the pointer in the string video. We're going to have a full video dedicated on strings in the future, probably after we have scanned the data. We're going to talk about strings because strings are a special thing in C, and we're also going to talk about arrays, which are also a special thing in C, both actually depending on pointers. But this is something that we're gonna get to in the future. So for now, we're just gonna have this as scanx, and later on we're gonna adopt this function to be a bit more nice. But now you can say that we have a proper input, and now I can also delete that bad comment, because now we have really a normal input as you would expect this. So now this function actually has one big issue. Well, let's try this out again, and now instead of entering a integer like 5, let's enter like that bad text. And if I enter that bad text to screw up our application, you can see we are getting some not nice outputs. So we're getting something that we really don't expect. And yeah, that's not really what we want. Can we try to figure out what's happening? Yeah, we can actually. We can actually try to figure this out. Let's maybe set this to a magic value, something to 55. And if I would set this starting as a magic value of 55 and try this out again, like screwing up our application, you can see that it now works, but it's like taking this default 55 value. So what you can basically see here or observe by this behavior is that when we initialize it to an initial value, for example 0, that when we enter something invalid, it is going to ignore that value that we entered here, and it's going to take the default one. So if scanf fails because the format here is not correct, so we are adding a string but we are expecting an integer, the scanf function kind of like doesn't modify the x, and that's good, but it's not really what we want, because now if we have in 0 here, how can we determine if the value was invalid, like ds, whatever, if that value was invalid, or if it was actual a 0 that was inputted by the user? Currently, we have no way to determine that. Well, we could try to cheat and do something like int 32 max, which is the maximum value of an int, and we could later on compare that x value if it is that maximum value. But still, if somebody enters the maximum value, we cannot really determine that. Of course, we could say, right, nobody's going to probably enter the maximum value, but what if somebody does? So it's really not a good idea to do this like that with a default value. We rather would get some feedback from the scanf function. Do we get feedback from the scanf function? Yes, we get some. The scanf function is returning an integer value. What does that value mean? I have no idea, so let's look this up. Or actually, I do have an idea of that, but we're going to look it up as well so that you learn how to do this. So one thing that I would always recommend is that you are not using like the first result that you get. Add a CPP reference. After that search of the function, add always a CPP reference. If you add CPP reference, you're going to get to the official documentation here. en.cppreference.com/w/c/io/fscanf. Formatted scanf. So there are a hell of a lot of scanf functions in here, and there's also the one that we use, the scanfs, which is a safe version. On Linux this might be issues because the scanf function that are safe, they are only defined in C11, so Microsoft by default allows them. On Linux you might need to, and also on macOS you might need to tell them explicitly that you are using C11 to be able to use them. So basically, as you can see, we have a lot of these functions. You can see that we have scanf here, the plain scanf for the one that we tried as we get started, and we saw that it did not support it. We have a scanf that is basically reading from a file. We're gonna get to file IO later, so writing and reading from files on the system. You can plainly also scanf from a file, so instead from the user input you can take a file and read from that, this formatted input. You can also do this scanf. This scanf works on strings, so you basically have a string, not the user input, a already predefined string, wherever this is coming from, maybe from the network or something like that. Okay, network could also be done with files, but this is a different topic. But maybe you are getting a string from wherever. Maybe you have an external library that does UI for you, for example Qt or any other UI library for C. And basically what you might get from this library is you get this string here, this const char pointer, which we are getting to what this is in the string video. And basically you might get this from somewhere else and you want to scanf on that input, and then you can basically use this scanf. Normal scanf input the default console, scanf from a file, scanf from a string. And down here we have the same functions again as a safe version. But all of them return an integer, and this integer is always the same. So let's scroll a bit down and see what we get. Alright, first parameters is defining the parameters that we use. Here's also the table that is showing these percentage signs and the actual following characters and what they mean. And if we are scrolling down, we are getting to the return value, which is basically describing what the return value of this function means. Alright, so now you can basically see that there are two distinctions. There is 1 to 3. And 4 to 6. So 4 to 6, what is that? Scroll a bit up. Alright, 4 to 6 are the safe versions, and 1 to 3 are the default versions. As you can see, if I scroll down again, is that the 4 to 6 values are the same than 1 to 3. And we also have an exception there. So maybe let's first understand 1 to 3 and then take a look at the exception that is basically special if we are using the safe version. Alright, so 1 to 3. Number of receiving arguments successfully assigned, which may be 0 in case of matching failure occurrence before the first receiving argument was assigned, or EOF if input failure occurs before the first receiving argument was assigned. So we have two cases that can happen here. One case is the second case. If input failure occurs, input failure basically means there's no more input that can be read. Input failure is kind of like an end of file. So for example, end of file is, if you're taking a look at a file or a string, very simple. If the string is finished before all the values were read. So if there was basically an empty file, a file that was already closed, that is already invalid, that is already closed, and it's kind of like at the end. If the file is at the end and it tries to read from that, it is returning end of file because it was not able to read from that. End of file, what is that? This is actually just a magic value. End of file is, if I click on that and that thing here, if I Control F for EOF for end of file, you can see that down here we have that macro constants and integer constant expression of the type int and negative value. So actually this EOF, it's just something that can be used here, for example, or actually we would rather use it above, so in a higher level use case. And this EOF basically means that there was an issue directly at reading that. This is not the only case that can happen. The other cases here is, let's close this and go back, is that it basically was able to parse that input, but it was not basically able to assign everything. So by default, number of receiving arguments successfully assigned. So the default value that we're going to get if something works is the number of arguments that were possible assigned. So in our case, we have one argument here. So what we would expect is that that function returns 1. So the scanf as returns 1 in case we were able to assign a value. So 1 is going to be returned if the value could be assigned. If we have two arguments in here, like we want to read two ints, x and y, for example, like so in the format like that, for example, and we would have an y, we would expect the return value of 2 if both of them were assigned. If we just get a 1, we know, alright, the first value was assigned, but the second one not, because it was basically the end of the string. So these are the two cases that we have. And actually end of file is probably returning -1. So as you can see, end of file is here at -1 and basically means that nothing was returned. So it could be treated similar to 0. So 0 argument was assigned, but it's returning -1 so that you can actually determine what's going on there. So now we understand that the default printf. What do we have as an exception for our safe version? Same as 1 to 3, so same behavior. We are going to get the number of arguments that could be successfully assigned. So we're always going to expect how many we inputted, and this is what we expect. And we have an exception here. So we can basically see that we can get end of file as well here in the safe versions, not only if input failure occurs, but also if there is a runtime constraint violation. So what the safe functions have is a constraint. This is only used for strings, as I already told you. Basically what you're gonna give it when you wanna read a string is you're gonna give it a constraint for that string. That constraint is gonna be the maximum length of the string. Gonna spoiler that right away. And if this constraint is violated, so the user inputted a string that was longer than the constraint maximum, this is also gonna return end of file. This is the only difference here. So the save version just also returns end of file here if the constraint was violated. So long story short, we are expecting a value of 1. How can we check this? Well, first of all, I wanna not do the error checking in the scanx function here, because the scanx function should just scan and not really check if it's successfully scanned, because we might want to use it in our main function to abort the application when we did a wrong scan. So what we basically want to do is we want to return the value that this scanf call returned us. So instead of an int32, because the return value of the scanf is an int, I want to return an int here. Also change this up here, and basically want to make sure that we return the return value of that scanf. Now this arises in one issue. Now we can no longer return the x value. We are using the x value, we are creating it here on the stack, and then we were returning it. But now we are returning the return value of the scanf function. So our x is actually lost. So we need to find the other way to populate the x here. And I'm going to do this very simple. I'm just going to say the parameter to that function is going to be a pointer to x. And now, because this is already a pointer, we can get rid of the pointer symbol here and just import x to the scanf, because it is already of the type pointer to int32t. So it is already a pointer, we don't need to make a pointer on top of that. But one thing that we need to make, of course, is we need to adjust it above here, and we need to adjust the call. So now it's no longer returning the x value. It's no longer returning x, it is returning the result. And so we would have something like int result equals to scanx, and then we would basically input x here, a pointer to x since we need a pointer here, and this now requires us to declare x here as well, and if we do this, we are fine. Now what I also want to do is I want to set this by default to 0, so that we basically have a 0 value here when we are scanning, and basically when we scan, we are overwriting this if the value is correct, and we are getting the result, which is basically indicating if this was successfully. So what I could do is I could add another printf here, and I could say success or red, then we do the %i parameters from user input, no, not form, from user input. There we go. And then we will basically also pass the result to that to get some information here. And what I also want to do, I want to terminate this with a dot and a space, because we are later on also writing to that. When we are talking about strings, I also gonna tell you how you can do a new line in C. We haven't talked about this yet. So let's get started by pressing F5 and see what we are now getting. So first of all, let's try it out by putting a valid value in here. Let's say 5. Alright, so the first output that we get is read 1 parameters from user input, and f from 5 is 55, f from 10 is 155, f from 15 is 305, and f from 20 is 505. Now let's try out putting nothing in here, just pressing enter. Okay, this doesn't work actually, because enter is just a new line. So that doesn't work. So if you still would enter a value, it would still work, because like new lines are accepted here. But now let's try out and adding some invalid text. So again, let's screw up the application. And now you can see read 0 parameters from user input. So you can basically see that the value was 0, but we are still doing the calculations here. Which might be okay if we want to do them with some default values, but this might also not be okay. Where I want to get to is that this is only executed if the user input is valid. So basically I don't want to add a default value here. And when I want to start this and input some trash, I just want to make sure that the code is not executed if we read 0 parameters. Instead of that, I want to show an error message that basically tells the user, hey, you need to input a text. And then the application terminates. This is the behavior that I want to have. But we are not at that point yet. We're going to be at that point in the next video, when we're going to talk about how we can inspect variables and how we can decide which section of our code is going to be executed depending on what we get as an input. So thank you for watching. See you in the next video. Make sure to like and subscribe, and have a nice day. Bye.